Hey, we're continuing our trigonometric journey here today. In our last video, we were focusing on exact trig values, and we kind of restricted ourselves to some really special angles that either fit in the first quadrant, like 30 degrees, 45 degrees, and 60 degrees, or we focused on the quadrantal angles. Today, we're going to kind of broaden our scope a little bit and focus on what are the trig values of any angle, like what if I'm not in the first quadrant? What if I make multiple revolutions one way or the other? So those are the types of things we're going to dive into. And hopefully by the end of this video, we're going to be able to answer things like this. Can we evaluate the sine of a monster like negative 35 pi over 6, or even string and do a bunch of multiplying and adding like we have here in these three different values between the sine, tangent, and cosine. So it looks a little overwhelming, but again, we're going to give you a game plan that's going to help you be really successful here today. The first thing we want to discuss is what are the signs, like SIGN signs of trig functions? When are they positive? When are they negative? So what we're saying is, first and foremost, if your angle lives in the first quadrant, okay, so we've got this triangle right here, first quadrant. All three sides of that triangle are positive, so every ratio is going to be positive. Every trig function is going to be positive, so that's a piece of cake. Once you get into the second quadrant, it starts to get a little finicky, okay? Now, your base is going to be negative, your height's going to be positive, and then your hypotenuse is always positive by default, okay? So now, in this particular case, when you go to do all your ratios, opposite over hypotenuse, adjacent over hypotenuse, that type of stuff, only the sine function and his reciprocal turn out to be positive. Everybody else uses the adjacent side here, and he's negative, so the answer comes out negative. All right. What if I jump into the third quadrant? This adjacent's negative, but also my opposite's negative, but my hypotenuse is positive. So when you go through those ratios, only tangent and cotangent turn out to be positive. Everybody else is negative. And then the fourth quadrant, you've got a positive adjacent, but you've got a negative opposite with a positive hypotenuse. So you work through those ratios, only cosine and his reciprocal turn out to be positive. So again, we like to use this goofy saying that says all students tip cows. How's that sound? Sound a little redneck? Yeah, maybe. Maybe you could say all students take calculus, whatever you can come up with. I'm sure you guys can come up with some really good ones on your own. And that moniker is going to help you remember who's positive, and then by default, everybody else is negative. So let's look at a couple of examples here. Name the quadrant in which angle theta lies if, okay, what if you knew that tangent was negative? All right, so when we draw our diagram, all students tip cows, tangent's positive in the first and third. So I'm going to cross those off because, again, less than means we want negative. So it could be this quadrant or this quadrant here, potentially. Now let's take a look at cosine. When is cosine positive? Well, all students, students tip cows. Okay, cosine is going to be positive in the first and the fourth, so we can cross off these bears. So let's see. I think the winner, when I compare these two diagrams, the theta must be in quadrant 4 because that's the only quadrant that satisfies both of these pictures, okay? All right, let's try this next one. So they said sine is negative. All students tip cows. That's going to be either this quadrant or the fourth. So we can cross off 1 and 2. And then they also want cosine to be negative. So cosine is going to be negative either in the second or the third. We could cross off these two quadrants. So what do we have in common? Which quadrant satisfies both of these conditions? It would be quadrant number 3. So that's just kind of a fun way to do those problems. Okay, let's get into something really, really critical. This is super, uber important. What is a reference angle? So first of all, theta be a non-acute angle. So that means acute would be between 0 and 90. So non-acute means it's smaller than 0 or it's bigger than 90. Its reference angle is going to be a positive acute angle. We're going to use the notation r with a subscript of theta, formed by the terminal side of theta and the x-axis. So every little detail in that definition is probably more important than we think. I'm going to change the notation right here to capital R subscript theta. Okay, so let's say for starters, we're in the first quadrant here. Here's your original theta. So in this case, the reference angle is the same exact angle. So what's the reference angle of 60? 60. What's the reference angle of 75? 75. So there's nothing fancy there. In other words, we could just say theta equals the reference angle. Things start to get a little more interesting, as they always do once you jump out of that first quadrant. Okay, so here's my initial angle. So the distance, here's my terminal ray to the x-axis. So this sliver right here is going to be your reference angle. How do we get the measurement of that slice right there? All we're going to do is we're going to take 180 and we're going to subtract your original angle. And that's going to give you your reference angle. So 180 minus theta tells you your reference. All right, what's going on in the third quadrant here? Again, you've got your original angle here. Whoops, I wanted to go highlighter. All right, here's your original angle. Here's your reference angle. How big's that sliver? Because you just want this little sliver right here. So in this case, what we're going to do is we're going to take the original angle right here and then subtract 180 from it. And once you take away 180, you're going to be just left with that sliver, and that's going to be your reference angle. Okay, fourth quadrant, you've got your original angle, and then you've got your reference angle right here. So all we're going to do is we're going to take 360, subtract your original angle, and be left with your reference angle. So those are kind of like a little cheat sheet for the formula, so to speak, for each individual quadrant. But really, I don't think it's about memorizing a formula so much. It's more about being able to visualize the angle in standard position and see how far the terminal ray is from the x-axis. So let's draw a couple here. So 345 degrees is going to be like way over here. So let's see if we could draw this. Here's 345. The reference angle is going to be right here. So all I'm going to do is I'm going to go 360 minus 345. That's going to give me 15 degrees as a reference angle. Okay. How about 5 power 6? Now converting that, that's going to make 150 degrees. So that's going to put you right here. So here's your 150. That means this guy here is going to be your reference angle. In visualizing that, we're just going to take 180, subtract the 150, and we're going to be left with that 30 degrees. So that 30 degrees is that sliver right here. Remember, here's a quick, if you go back to that definition, remember we said reference angle's got to be positive and it's got to be acute. So make sure your answer is always positive and make sure your answer always falls between 0 and 90, and you got a pretty good chance of being right. Okay, negative 135 means we're going to rotate this way. And that's going to put me right here on this dot right here. So here's my angle. That's my negative 135. This is going to be your reference angle right here. So in this particular case, there's a couple of different things we could do. Okay. You can basically just subtract 135 from 180. All right. And that's going to give you, what's that going to make? 45 degrees. So you can just see this gap right here is going to be 45 degrees. The other thing you could do is find the coterminal angle. Just add a revolution. Okay. That's going to make 225. And then you could draw 225, which put you here. And then you could say, oh, third quadrant. So it's going to be, 225 minus the 180, and you'll get your 45 degrees. So however you slice it or dice it, you're going to get your 45 right there. Now, here's a really, really weird one. This is going to be in radians. That's 2.5 radians. It does not include the pi. Now, if you remember from an earlier video, we kind of talked about 1 radian is about 57 degrees, or 60, depending on how accurate you want to be. So 2 radians is going to be about double that, so about 114. 2.5 is going to maybe put you, let's see, 39. It's going to put you in the 140-ish ballpark. So it's going to put you like right here. Either way, your reference angle is going to be this sliver right here. Okay. And so instead of saying 180 minus the original angle, I'm going to say pi because we're in degrees. Pi minus 2.5. And you could throw that into your calculator, or you could just leave it in terms of pi. So pi minus 2.5 is going to be your reference angle. That was a weird one, I know. Okay. Here's another thing you want to watch out for. And we kind of saw this a little bit in that last example or the two examples before this when we saw that negative angle. What do you do if your angle's bigger than 360? Or what if you do if it's smaller? Oh, shoot, I should have less than 0. Change this. This should say 0 right here. Well, what if it's less than 0? Basically, what if it's negative, right? Well, our goal is always to find a positive angle that's smaller than 360. So in other words, what we're saying is we want to find the coterminal angle. So in a nutshell, if you have a really big angle, all you want to do is subtract 360 as many times as necessary until you get below 360. If you have a negative angle, all you're going to do is add 360 until you get to a positive angle, okay? We're going to draw that new angle in standard position and then use that drawing just like we've been drawing to try to find a positive acute angle, that measures the distance between the terminal side and the x-axis, okay? So let's see if we can put that into motion, because again, that sounded confusing when I said it out loud. Okay, you'll notice this angle is very big. It's bigger than 360. So we're going to subtract 360. And that's going to give you 220. This is called, if you want to make a note right here in your notebook, 220 is the coterminal angle of 580. Now you can draw yourself a little picture. 220 is going to be about right here. And if I do 220 minus 180, that would give me a reference angle of 40. Okay. Now remember, 220 is not your reference angle because that's too big, right? A reference angle has to be acute. 220 is just your coterminal angle, and then 40 is your reference angle. Okay. Now notice how I subtracted 360 here. What you can do is you could just subtract 2 pi if you want. And in this case, 2 pi would be 6 pi over 3, leaving you with 2 pi over 3. Again, if you want to make a note in your notebook, that's coterminal. And of course, another alternative is just convert that 8 pi over 3 into degrees right away. And I think when you do that, you're going to get 480. Subtract 360 is going to give you 120. So whether you express it in radians or if you express it in degrees, you're going to get the same answer. If you draw 120, that's going to put you right here. Your reference angle's right here. 180 minus 120 gives you a reference angle of 60 degrees, or you could say pi over 3 radians, depending on how they wanted the answer. Okay, now our last one is not really big. It's just the opposite. It's really, really small because you'll see we've got ourselves a negative angle right here. So why don't I do this? I'm betting what you're going to be more comfortable converting it to degrees first. So let's see. Negative 13 times 30. How about negative 390? So yeah, all I did is I multiplied that angle by 180 over pi, and I got negative 390. So in this case, you want to add 360, but you'll notice your answer's still negative, and you're like, shucks. Okay, so add 360 again, and you'll get 330. Make a note in your notebook. This is your coterminal angle, right? Okay, if you want to draw a picture, that's great. I'm always a huge fan of drawing the picture. So here's 330. Your reference angle is going to be this sliver over here. 360 minus 330 makes 30. Bingo, reference angle 30, or pi over 6. Now, we still haven't gotten to where we want to go. At the end of the day, what we really want to be able to do is evaluate these trig functions, right? So what we're going to do is we're going to focus on finding our reference angle. And also we got to think about what quadrant that reference angle lies in so that we could prefix the appropriate sign, whether it's going to be positive or negative. So in that case, think all students tip cows. The most popular thing is I'll see students get this part right and then just forget about, the sign, and they'll do everything right but the sign. And that's a real killer. Okay. So the reference angle right here, let's just draw 135 is going to be right here, right? That's quadrant 2. Sine is positive in quadrant 2, so that's a good thing. And then your reference angle is 45. So this is equivalent to the sine of 45, which is radical 2 over 2, positive radical 2 over 2. Okay, one thing you could do on this next one is rewrite it in degrees. So 4 pi over 3 is going to be 240 degrees. Draw yourself a picture of 240. Now that's third quadrant, right? So what you're going to end up with is we're going to end up with a negative answer this time because only tangent and cotangent are positive there. So this one's by default's got to be negative. Your reference angle is going to be this sliver right here. 240 minus 180 makes 60. So negative cosine of 60 degrees. So negative 1/2 is my answer this time. Like I said, I get a lot of talented students. They'll tell me the answer is positive 1/2. They did everything right. They just forgot to prefix the sign there. All right, a couple of bigger, uglier bears. We could certainly rewrite this as negative 60. Since it's negative, we're just going to add 360. Draw yourself a picture. That 300 is called the coterminal angle, right? Here's 300, so the reference angle is over here. That's going to be 60. And a lot of times, I don't know cotangent of 60 off the top of my head, but what I'll do is I'll do the tangent of 60 first and then just reciprocate it, right? So if we know that the tangent of 60 is just radical 3, reciprocating that is going to make 1 over radical 3 or radical 3 over 3 if you got to rationalize it. Now, what quadrant were we in, right? Well, we were in the fourth quadrant. So that means only cosine's going to be positive. This guy's got to be negative. Attach that negative every step of the way and make sure we got that negative in the answer. All right, here's a real big, crazy one. Let's try, if I multiply that angle by 180 over pi, I think that's going to come out to be, let's see, 1050, I hope. Oh my God, what an enormous thing. So that's several revolutions, right? Every 360 is a revolution. So I'm going to subtract 360. Oh my gosh, that's going to give me 690, I think. Still way too big, right? Subtract 360. That's going to give me 330. Okay, now we're in that interval. This is your coterminal angle. So I'm going to do sine of 330. Draw yourself a nice picture, right? The sliver over here is 30, and we're in the fourth quadrant. So I'm going to go negative sine of 30, which makes negative 1/2. I almost tried to say radical 3 over 2, but that's going to be negative 1/2. Again, just got to watch your quadrant and make sure you get the sign right. Okay. Last, let's finish with a bang, huh? Let's finish with a bang. Let's rewrite everything. Let's rewrite everything in degrees. So that 3 pi over 2 is going to be 270. That's a quadrantal angle. And then we'll do the tangent of negative, let's see, negative 480. All right, plus the cosine of negative 150. So the first thing I'm going to do is I've got to add 360 to these negative angles. So that's 2. That's a mess. Got to clean that up. Come on, Hill. Let's go 270. All right, tangent. So if I add 360, I'm going to get negative 120. So I had to add 360 again to get 240. And if I add 360 right there, I believe I'm going to get 210, right? So we'll do cosine of 210. Now, again, this first one's a quadrantal angle. So what you want to do here is I think you want to visualize your unit circle and grab the y coordinate of 270, and that's going to be negative 1. For 240, we'll draw ourselves a nice little picture. Good news here is we're in the third quadrant, reference angle 60. So we'll do tangent of 60. Third quadrant means tangent's going to be positive. 210 is going to be still in the third quadrant, but this time cosine is going to be negative. And your sliver right here is 30 degrees. So let's say we got -1 multiplied by radical 3, subtract radical 3 over 2. So let's say, I think finishing it up, we'll just say negative radical 3 minus radical 3 over 2. And I'm totally okay with that. If they want you to express it as one single fraction, you'd have to go common denominators and go, -2. So how about -3 radical 3 all over 2, I think would do it. Thanks for hanging in there. I know this wasn't the shortest video ever. We covered a lot of information. And again, anything that we went too fast on, just throw it in the comments down there below and we'll try to walk you through it and make sure that you feel real confident with evaluating these trig functions.